Let's look into another question. Determine the reaction loads at point A and C. Again, in this one, I wanted to find the reaction load. So if I'm trying to find the reaction loads, I need to draw the complete body diagram. So I'll start with the complete body diagram. So this is the complete body diagram, and then there is a rope in this direction also. So I have to show two ropes, and one in the vertical direction, another at an angle, and both will have a tension of 3.4 kilonewton because both are joined via, that's the same rope, shall I say, that's the same rope, and direction is changed via pulley. So this is 3.4 kilonewton, and I wanted to show the reaction loads now. So reaction loads at point A, I can show it this direction. This is another one because this is a pin joint, so this will be RAX and RAY. Wherever there is a pin joint, we show X and Y components of the reaction load. And then there is a smooth surface at this end at point C. So for the smooth surface, again repeating, if it is a smooth surface, then you will draw the reaction load in the direction perpendicular to this smooth surface. So this, if this is the surface, the reaction load will be perpendicular to this surface. So I'm going to erase this. If this is the surface, reaction load will be perpendicular to this surface, and the slope of this will be opposite because these two are intersecting each other at 90 degrees. So this will be 4, this will be 3, and this is point C. And what I can do is I can take the component of this also. This will become CX and this one will become CY. And now I wanted to write down the equation. So first of all, I will write down the moment equation. I'll take the moment about A, which is equal to 0 because it is under the static equilibrium. So if I start taking the moment about point A, so it will be starting from this CX. So CX times, I should put a dot here rather than multiplying with X, showing a multiplication symbol. So this dot represents the multiplication symbol, times this distance is 0.6, and then this is counterclockwise or clockwise. This is clockwise. So this CX is trying to rotate it in clockwise direction about point A. So this will be negative, and then again, because we've assumed that clockwise, any motion, any force which is trying to rotate the body in the clockwise direction will be considered as negative, and counterclockwise will be considered as positive. So this is negative, and minus CY, again trying to rotate in clockwise direction, so CY times the distance is 0.7, and then there is a force of 3.41 kilonewton plus 3.41. This is trying to rotate it in counterclockwise direction, so this is 3.4 times 0.2, and then another force of, then this force is acting at a slope 15. This is 15, this is 8, this is 17. So I can find the X and Y component of this force also. So there will be a Y component and there will be an X component, and the value of Y component will be 3.4 times 17, 3.4 times 15 divided by 17, it will be 3. So this value comes out to be 3, and other value will be 3.4 times 8 divided by 17. This value is 1.6. So this 3 3 kilonewton is trying to rotate it again in the counterclockwise direction, so I'll keep it as positive. And this value will be positive 3 times 0.2, and then this value plus, this is also trying to rotate it in counterclockwise direction, so this is again positive, about point A. So this is 1.6 times 0.6. Seems like I'm in a habit of representing the multiplication sign. All right. Now let's solve this equation. Before I start solving this equation, I will also write down the relationship between Cx and C. So Cx, I'll write it on a side. Cx is equal to 3 over 5 C, and Cy is equal to 4 over 5 C, and this is C here. So now what I'm going to do is I will feed these values in this equation. So this is 3 over 5 times 0.6 C minus, this is a negative value, 4 over 5 0.7 C, and then I can calculate these two values, these remaining values. So 3.41 times 0.2 plus 3 times 0.2 plus 1.6 times 0.6, which is 2. This value comes out to be 2.242, and then I can take this negative sign outside, and I'm going to write these values. 3 times 0.6 divided by 5 is 0.36. This is 0.36, and this value is 4 times 0.7 divided by 5, which comes out to be negative 0.56, and I'm going to take C as a common because C is common in both the values, and this value goes on the other side of the equation, becomes a negative value, negative 2.4242, and negative cancels out, and this is positive. So 0.56 plus 0.36 will give me 0.92. C equal to 2.242, dividing both sides by 0.92, and C value comes out to be 2.242 divided by 0.92, which comes out to be 2.436. I can write it as C equal to 2.44, and the units will be kilonewton. So I figured out the C value. So what I'm going to do is, because I don't have enough space, so I'll erase this section now, and I will try to solve for Rax and Ray. So let's write down the equations in the horizontal direction. Sigma f of x equal to 0. So I will write Rax because it's a positive value. It's acting in the right, towards the right hand direction. So I'm gonna take this value as positive. So Rax minus or plus. So is there plus 1.6, and then Cx is acting in the opposite direction. So minus Cx equal to 0. These are the three horizontal forces acting on the structure. And then if I wanted to find Rax, Cx value, I can find it from here. Cx is equal to 3 over 5 times 2.44. So 2.44 times 3 divided by 5. So this value comes out to be 1.46. So negative 1.46, and 1.6 minus answer and RAX comes out to be 0.136. Let me check the answer for RX and CX, and this value, C value, is correct, and RAX is also correct. This value is also correct. And similarly, we can find sigma f of y equal to 0. We can find the vertical forces also, and then I'll write down the equation for the vertical forces. This is a little interesting. RAY is acting in the downward direction, so I'm taking it as negative. This 3.4 kilonewton is acting upward, so I'm going to take it as positive 3.4, and then 3 is also acting upward, so I'm going to take it as positive, and minus cy equal to 0. And we know the value of cy is equal to 4 multiplied by 2.44 divided by 5, which comes out to be 1.95. so this is negative 1.95 equal to 0, and this is plus 3.4 plus 3 negative RAY, and this 3.4 plus 3 minus 1.95 will give me 4.45. so RAY is equal to 4. So this is 4.45, and this is positive, gonna go on the other side, becomes negative. This is negative, so this negative cancels. Our RAY value is 4.45, and the direction we've assumed is correct. But here in RAX, I should have taken this direction when I moved it on the other side as a negative direction. So RAX is this is RAX is, oops, I'll complete this, not enough space here, so I'll write it here. RAX is negative value, so I'm gonna write it as RAX equal to 0.136 in the opposite direction, like this. And that's it for this question. Let me check the value for y also. This is correct value. All these values are correct. So hopefully you were able to understand this question. So thanks for watching. See you with the next question.